Okay, in this lesson, we're going to be looking at the slope of a line. Slope of a line. Um, what that is a ratio. We should all know what a ratio is. It's a nice line there, isn't it? A ratio is basically a fraction. It compares two numbers by division, two quantities. It is the ratio of the line's vertical change. That's the up and down change, and that we call that the rise, to its horizontal change, which is the left and right change, which we call the run. And so the ratio is just simply written like rise over run, or you may say it is change in y divided by the change in x. Okay, so it's basically a measure of the line's steepness. We can tell this, the number that we get for the slope tells us how steep it is. There are four different possibilities for slopes. You can get a positive slope, a negative slope, a zero slope, and an undefined slope, which we're going to look at here in a second. So if you normally you read from left to right, when I say normally, it should be all the time, okay? And you read graphs from left to right. And so when we read this graph from left to right, if the line is going, if it's like you're walking uphill going from left to right, you have a positive slope, okay? If you're going from left to right and it's like you're going downhill as you go from left to right, that is called a negative slope. Okay, negative slope just denotes going downhill from left to right. Well, if it's a horizontal line, you get horizontal lines when you graph stuff like this. Y equals 2. I think this is y equals 3, in fact. We call it a zero slope. Notice you're not going up, you're not going down. It's just a zero slope. There's no rise, there's no fall. Okay, and here you get stuff like this when you graph like x equals 6. Okay, because that's a vertical, this is a vertical graph, vertical line graph. When you have a vertical line, we call that an undefined slope. Okay, something you think of it as something you can't walk up. So that would be an undefined slope. We'll see why it's called that later, but not right now. So if we're looking at a graph and we want to determine the slope of the line, well, it's pretty easy. We're generally given 2 points. Let's see if we can get a different color here that might help us a little better. So we got a point here, and we got a point here. And remember, the slope is the rise, the vertical change over the horizontal change. So we're going to have a fraction. Okay, so from this point to this point, what is the vertical change? In other words, how far up do I have to go to get from here to here? Well, I go 1, 2, 3, 4 up. That is the vertical change. That's the top number in my slope. Okay, now how far over do I have to go? Well, if I go 1, 2, 3, 4 up, then I go 1, 2, 3, 4, 5, 6 over. So that's the bottom number. 4, 6 is my slope. I can reduce that and we can leave it as 2/3. So this one has a slope of 2/3. Let's look at this one. I'm going from this point to this point. Okay, so I go up. Remember, now up is a positive distance, down would be negative. It doesn't matter which point I start with. If you want to go left to right, we can do that. Let's start at this point. I actually have to go down to get where this point is. So I would go 1, 2 down. That would be my top number. 2 down is a -2. Then I go over 1, 2, 3, 4, 5, 6, and 7. And I can't reduce that, so my slope for this one is -2/7. Let's look at this, and for some reason I only have 1 point on here. Let's see, let's use this point right here. Okay, we'll put a point there. Okay, so I'm going to go, this is a positive slope, so I'm going to have a positive answer. 1, 2, 3 up, that's my top number. And then my horizontal change is 1, 2, 3, 4, 5, 6, 7, 8, 9. 3/9, that reduces to 1/3. That is a slope of 1/3. Okay, let's look at this slope. From this point, 1, 2, 3 up, that's my top number. Over 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 3/9, which is 1/3. This slope, well, what's my vertical change? It's not much. I go up 1. Okay, so I have a top number of 1. Then I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. So it's a slope of 1/16, and it is positive because it's going up. Now this one should be negative when we're through. Okay, so my vertical change is going down, so I'm going to get a negative number. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. I think I counted that right. If I didn't, I don't know. My eyes are kind of crossing when I'm looking at this thing. So I'm going 15 down, then I go over 1, 2, 3, 4, 5, 6. 6 over. I can reduce this, but I don't want to make it a mixed number. I'm just going to reduce it by 3. So I get 5 over 2, and it is negative. So I have a slope of 5 halves. And we don't want to make it a mixed number for reasons you don't know now, but you will know later. We're just going to leave it improper. Okay, but I should have positive slopes. They should be positive here where my negative slopes are. I should have a negative on it. Okay, that's how you find slope from a graph. Now finding slope from 2 points is pretty easy. The formula is given by this, m, which always means slope in math. We see the letter m, it's talking about the slope. y2 minus y1 over x2 minus x1. These are called subscripts. They don't mean it doesn't mean you square the 2 or do anything mathematical to the 2. It just means I've got more than one y. So I need to differentiate which y is which. Okay, so if I had like 3 ordered pairs, I would have y3, y2, yn1. So it's just telling me I've got 2 different y's here, and I need to say, well, one of them is y sub 1, one of them is y sub 2. There's nothing mathematical about it other than just differentiating between the 2 y's. So the easy way to do this, to use the formula, let's get this mess off the formula so you can see. Okay, so what I do is I label each point. One of them is x1, y1, the other one's x2, y2. It doesn't matter which one is x1, y1 and which one is x2, y2. It only matters that the one here is with the one here. I don't make it x1, y2. It's x1, y1, x2, y2. Okay, I could switch the groups, but I can't interchange in between. I need ones in one and twos in the other. Then plug the numbers in. y2 is 7, minus y1 is 2, over x2 is 4, minus x1 is 1. Well, 7 minus 2 is 5, 4 minus 1 is 3, so my slope is 5/3. Okay, so it is positive, so I'm going to be going up as I go from left to right on the graph. Let's look at this one. Same thing, x1, y1, x2, y2. Okay, so I'm going to use the formula, y2 minus y1, that's 1 minus 5, over x2 minus x1, that's 6 minus, well, I've got a negative 2. So 6 minus negative 2, 2 negatives become positive. So on the top I get negative 4, on the bottom I get positive 8. That reduces to negative 1/2. So I have a slope of negative 1/2 there. Okay, again here, x1, y1, x2, y2. Plug the numbers in where they go, y2 minus y1 over x2 minus x1. That's just negative 9 over 3, which is equal to negative 3. That's a bad 3, but that's what it is. Okay, negative 3, negative ugly 3. Next, do the last one here, x1, y1, x2, y2. Plug the numbers in where they go. 8 minus 0 over 7 minus 5. That's a minus 5. I get 8 over 2, which is equal to 4. And we're done with that. Look at the next one. Let's look at the zero and undefined slopes. Let's see why it's called zero slope. Well, let's do it this way. x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. That gives me 0 over 9. Well, 0 over 9 is just 0. Anytime you have a horizontal line, you're going to get a 0 on top. So that's what we call that a zero slope. Let's see why we call this a horizontal, vertical line a undefined slope. x1, y1, x2, y2. So it's negative 6 minus 5 over 6 minus 6. Well, that equals negative 11 on top. That equals 0 on the bottom. You can't divide by 0. Anytime in mathematics, when we divide by 0, we call that undefined. So that is why this one is called an undefined slope, and this one is called a zero slope. That was just for your information. Not that you have to do anything with it. You just need to know why they're called that. Okay? Look at a real life problem. Okay, here I'm given a graph showing the distance. The y-axis shows the distance in feet. The x-axis shows the time in seconds. Okay, it says the graph shows the distance traveled by a wakeboarder as a function of time. The slope of the line gives the wakeboarder's speed, which is the rate of change, and distance traveled with respect to time. Find the wakeboarder's speed. Okay, so to find the speed, remember speed is like miles per hour. That's a ratio. You got miles on top, you got hours on bottom. We can also find speed with feet per second. That would mean feet would be on top, seconds on bottom. Well, slope does that for us. It puts y on top, the change in y, and you divide it by the change in x. So we're just going to find the slope of the line. That will give us the speed. x2, y2, x1, y1. Does it matter which one's x2, y2, and which one's x1, y1? You'll get the same answer. So it's y2 minus y1 over x2 minus x1. Solve this. We get 130 over 5. Okay, that's going to give me 26. 130 divided by 5 is 26, and that is feet per second. So the wakeboarder speed is 26 feet per second. So anytime I'm dealing with feet here in seconds, the slope is always the speed. The speed. Now you'd never have in real life a constant rate of speed for a wakeboarder. Okay, it's going to be changing and fluctuating. But for the ease, just for learning about slope, this is it's going to be a constant thing here. So 26 feet per second is how fast the wakeboarder was going. Okay, now let's look at finding slope using an equation. And it's very easy. The slope is always located in front of the x. The slope is not the x. The slope is the number in front of x. It's the coefficient of x. Okay, so in this case, the slope, which is represented by m, would be 3. Pretty easy. Let's look at the next one. What is the coefficient of this x? Well, it's negative something. It's negative 1, right? Negative 1. So the slope in this one is negative 1. Now, these are in different forms in this, so what you always have to do when you're finding slope of a line, you always have to put it in this form. So here, let's write this over here. We got 3x minus 4y equals 10. I'm going to solve for y. So I subtract 3x, negative 4y equals negative 3x plus 10. Okay, negative 4, divide by negative 4, divide by negative 4. Y equals 3/4 x minus, we'll call that's 10/4, we'll call that 5/2, minus 5/2. That doesn't matter. Now, once it's solved for y, I look in front of x, and that tells me the slope. Sorry, m is equal to 3/4. Pretty good. Okay, next one, negative 2x minus 3y equals negative 5. I'm going to add 2x to both sides. I get negative 3y equals 2x minus 5. Solving for y, I want to get rid of the negative 3. Had to do that by division. I get y is equal to negative 2/3 x plus 5/3. I don't care about this, I only care about this, the number in front of x. That is the slope. M is equal to negative 2/3. Two more things and we're done. Now if I graph x equal negative 3, just think about this. I get a vertical line. What kind of slope does a vertical line have? Well, it has an undefined slope. Anytime you have x equals something, it's an undefined slope. Okay, when the y is gone, just have x, undefined slope. When you have y equals something, when I graph that, that's a horizontal line. So we would call that a zero slope, or m equals 0. Okay, so anytime you see y equals something without an x, that means we have a slope of 0. And that concludes today's lesson.